Hello, everyone, and welcome back to another episode of Changing the Game, powered by Rockwell Automation. I'm super excited for our next guest who will be joining us very shortly. His name is Martin Keuchkerian. He played some pretty awesome years in rugby, has done a lot of other cool things in the sports world, and studied and completed his degree in aerospace engineering. So I'm excited to have another athlete that's also an engineer on the call. On our last segment, we had Rhea Coble, who also had a master's degree in material science and engineering. So it's great to see these absolutely incredible athletes also doing really incredible things in STEM. So stay tuned. Let us know where you're tuning in from as we wait for Martin to hop on so I can add him in to the chat. I'm super excited to start asking him some questions. And let's see if we can get him to hop in. Let's see if I can invite him in real quick. So, again, make sure that you use... Oh, there we go.
Awesome. Hola. Hi, Jay. How's it going?
Pretty good. Yourself? Let me slide this up real quick.
Amazing.
All right. Instagram changed the features on me a little bit, so I had a little mix-up there. But I'm glad you're able to join us. I'm glad you're here with us today. I was just telling the audience that we're super excited to have another athlete that's also an engineer. Our last guest had a material science engineering degree from Stanford. She had her master's there and is an incredible endurance athlete. So if you didn't get to check out that episode, make sure you guys head over to YouTube and check that one out. But I'm excited to have you on today. Definitely in the chat, I've already seen people sharing what countries they're coming in from. I see Brazil. I see other parts of South America. I know you have some ties to Uruguay, correct?
Sí. I was born and raised in Uruguay and moved to the US when I was 15.
Excellent. So let us know what countries everyone's coming in from, what your team numbers are, what you're excited about, and throw in any questions that you guys have for Martin. But let's get started. Let's get right into it. So I wanted to know a little bit about your background growing up. Were you always into sports from an early age, and were you always into STEM from an early age, or how did that path towards both of those worlds kind of develop?
So, yes, for sports, not so much for STEM. I would say since very, very young, I started playing soccer when I was 5. I was always very active, very hyperactive, I would say. So I always was in the move, always trying to do something. And my mother, the best way to get my energy out was to get me in sports. And since very early age, I tried a whole bunch of sports. So played soccer, handball, basketball, gymnastics. I did swimming for some time, tennis, handball, some martial arts, boxing. And then I found rugby. And even though I tried other sports while playing rugby, rugby was always the one that always interested me the most, the one that just was perfect for me. And that's what made me, play for 13 years and take it to such a level. As far for STEM, I think I developed that interest in STEM during high school when I took my AP physics class. And it was mostly thanks to my teacher. He was a mechanical engineer, and he was a professor in charge of the robotics club at my high school. And his whole class was focused about, learning physics and how to be an engineer, not so much about the AP exam. So although we did really well in the AP exam and we studied, his class was very much project-based, making calculations, doing theory behind prototypes, and then actually designing catapults, carts, Roseburg machines, and a whole bunch of little projects that got us super excited about wow, this is really cool applications of physics, of mathematics. And that's definitely what got me interested in pursuing a STEM career.
That's amazing. I think it's so powerful. That similar to me, when a teacher can share that with you, hey, you should try this out or look into this field, and then provide some of those hands-on activities that bring it to life. It's absolutely incredible. and first is one of those best ways to get that hands-on experience so that you're not asking why would I ever need to use this again in my life. I feel like those hands-on projects can give you some of those kind of experience that help you take it to the next level. Was there a particular project that you remember was your favorite, or that put on a light bulb for you, like, wow, this is why I think engineering is right for me? Or was it a combination of those? How did you then decide from, I like this physics class, to I'm actually going to go and study this as my major?
Mhm. I think I always knew I wanted to do something with space. Ever since being a little child, my dream was always being an astronaut. And as I grew up, I like was interested in other things, but I was always like that little like child's dream of like going to space, going to the moon, going to Mars, always stuck with me. So I knew that all throughout high school, I wanted to do something with space. I just didn't know exactly why. And when I took that class, AP Physics class, and then I took Physics 2 with another professor that was very much project based, it was something that it was like, man, I absolutely love to do this. So I think the two main projects that really inspired me were a mousetrap power cart.
Okay.
So we were given like pieces and we could bring stuff, but we really had to try to calculate and like guess, like, well, not guess, sorry, but like calculate and estimate,
Yeah.
how far will it go if we have this much force coming from the mousetrap and we put this arm, what the momentum will be, what the friction will be, and try making a cart and testing it against that theory was really interesting. I was like, like I was pretty far off. Why was that? And you get into digging into like, like concepts of friction, and obviously like theory is very different than real applications. How can we make the model better? And that was amazing. I remember spending so many hours after class just on the class and like with my professor, just taking pieces. He taught us how to use a lot of like machines, like woodworking, and a lot of like metalworking. So we were there just learning a lot, and it was like, oh man, like this is how I want to make my change. This is how I want to make my career in space, doing exactly this. And that's how aerospace engineering was like the perfect mix of both.
Okay. I love that you shared that it didn't go right the first time, that it didn't work out how you were expecting it to happen. And I feel like our teams can really relate to that you have this thought of how your robot's going to work and what exactly is going to happen, and then you got to put it into practice, right? And sometimes it doesn't happen the way that you expected, but you go back to the drawing board, you learn a little bit more about some of those areas that maybe you were putting some estimates into and need to do a little bit more research, or talk to an expert or a mentor. I think that's such an important part of the process that everyone should get comfortable with, especially when you're trying to do things that have never been done before, because there's always going to be those kind of roadblocks or dead ends, but that's part of the process, and you got to get comfortable with that.
Yeah, exactly. Like you said, like STEM and engineering, I feel like it's a lot of like, failing and learning. We have a lot of theory, but when we apply it, especially in the aerospace world, like, fluid dynamics, all these things that we have a pretty good understanding, but everything is not exact. And we need to test, we need to have theories. And sometimes where our theories are wrong is when we learn the most. It's when we go completely back to the drawing board and we like start revising everything. It's like, oh man, like, yeah, we need to change here. We need to make adjustments here. And that's when the best designs come. When you have a failure, you revise, fix, and you go on to the second prototype.
I love it. So as long as you learn something from it, then it doesn't end up staying a failure, I guess, right? It's still a
Exactly.
step towards success. That's great. And I'm seeing so many good comments. One, I want to point out, great teachers are worth more than gold. Again, thank you to all the teachers, especially during these challenging times. Someone said, so smart, not everyone can do that career. I'm going to disagree with that. I think anyone that's curious, that is passionate about something, can then go on and learn some of the things that are required. And I think your story kind of proves that.
Absolutely. I will say that more than anything, if I was able to make it, it really does mean that anybody can. I love physics. I was very curious, but I was never the best by any means. I wasn't the best at math either. And those two are the essentials. But
Yeah.
I really loved it. I really loved what I was working on, and I knew this is what I needed to learn in order to get there. And going through office hours, having mentors, having friends helping me, teachers like that I could reach out to, they made it possible. So it's not
Okay.
like this myth of like you need to be really smart is really not true. It's just wanting to learn, having that drive, and what my mother always used to say, querer es poder. So like if there's a will, there's a way, and if you really like it, you can definitely make a career of it.
Great, that's perfect. So again, you just need to be curious. You need to work after that, and you can make your way. I had the same thing. I was very passionate about it, but I wasn't necessarily the best at math. Calculus was very difficult for me, and physics was very challenging for me. I loved materials. I loved some of my other classes that were more on the mechanical engineering side, but sometimes you still have to get through those initial hurdles in math and other subjects. But first, I want to say, I mean, there's love from everywhere in here. Brazil, there's a team from Israel. I see Ecuador, Honduras, Uruguay, Puerto Rico, República Dominicana, Dubai, India, all over the U.S. I see some other languages that I can't read, so we've got love from all over the world. Keep sharing where you guys are from. Give Martin some love. And we're going to transition now back more towards your rugby life in this space. So if you guys have questions about what he shared in STEM, please throw them into the question section, and we're going to talk some rugby, and we're going to put them both together. So I'm excited to be able to kind of mix these two worlds of sports and STEM, which is the goal of changing the game here and showcasing to our viewers what are some of those opportunities that we don't see outside of the field or off of the court. Exactly. And so you mentioned, you did have that passion early on, and rugby became the love of that. What are some of the things in rugby that an average person might not understand? There's like a lot of science or engineering behind it. Like what is something you might be able to open our eyes to in the STEM side of rugby?
Yeah, so I think rugby, as far as like STEM, and physics of rugby, things like that. It's a very, like you said, very complicated sport when we start looking at it, because the main thing is the ball. The ball is like sort of like a football, but very much like a lot more oval shaped. It looks like a over pumped football, very big, very fat. So
I'm going to put sorry to interrupt you. I'm going to put the rugby emoji into the chat so you guys can see that. That's what the rugby ball looks like.
Yeah. And it doesn't even have the little things where you put your fingers like in a football to very grab it and throw it. It's completely smooth with some like grip to it. So what happens is the physics of the ball is very interesting. It's very, very much not aerodynamic.
Okay,
not
interesting.
the best design. And because it has so much air, it's very airy, and like it like bounces a lot compared to a football. So a lot of very interesting like skill and important like hard step to like learn in rugby is kicking, for example. Okay. But kicking is something that rugby players use a lot. It's not like football where you have like you 3 downs and then you kick, or you kick to post. In rugby, you grab the ball and you're running towards the offense, and you can just kick it right over. But you need to be very aware of the shape of the ball, where you kick, right? Because if you kick a ball, it's an oval shape, right? If it's sending vertical up, the elbow's here, and you kick it just in an angle like downwards, like if you were gonna kick a soccer ball to have it going forward and up in a parabola, it would actually just start spinning in place because most of the force is going horizontal, start spinning in place, and sometimes even go backwards because of the force of the air. So it's something very interesting that when you start looking at it, there's so much interesting physics happening behind that. How the air is going around the ball, creating like high and low pressure areas around the ball, and the air around it is actually pushing the ball to go, instead of up, and sometimes even backwards. So it's something very, very interesting that a lot of people like don't consider about
Yeah.
rugby, and as well, obviously, like for example, the hits, the hitting, a lot of physics involved on how to transfer the momentum from one
Okay.
plane to another and do it safely. So a lot of techniques are taught to players on body positioning, tackling techniques. But when you break it down, is a way of safely transferring momentum so both players are safely as possible when the hit is happening. So there's a lot of hidden physics that you can really study when you start like looking in depth into rugby and all these actions.
Yeah. Someone just commented that makes perfect sense. People don't realize how much math and other STEM subjects we use in our day to day. And this is one that you would never think of. You know, you think of rugby, some big, strong people just running around after a ball and hitting each other, and you don't necessarily think of how much physics could be involved in that process. And so, would you go as far as saying that understanding physics could make you a better rugby player, even if you didn't necessarily get stronger that day, but having an understanding of how physics applies to the ball or to the hits could actually make you better without even getting any stronger or faster?
Mm-hmm. I would say most definitely. And actually, we do technically teach physics to kickers without going in depth into like aerodynamics or
Yeah.
fluid dynamics and things like that. But we do teach like vector like forces and how like the example I just gave. Like we teach if you kick it this way and you kick it like from an underside and you do this, the ball is going to start doing this. And the reason why is because you're giving it most force here. So
Okay.
if you just change the angle of the ball slightly, so you kick it into like a perpendicular line across the ball, it will transfer all the force directly through the ball and go more higher now. Also,
Okay.
if you kick it from the harder side, so the ball, because it's oval shape, most of the pressure goes to the sides. That's where the plastic part of the ball like stretches the most, and in the ends where the posture is, it gets like the toughest. So if you kick it in the toughest part, is the least displacement of the ball, the least like deformation, which make it go longer. So basically, if you want to make a long kick, you want to change the angle and kick it on the end. That will give it the most transfer of force into a straight line. And if you want to do a high kick, a kick that players often use to like go chase and catch, you want to kick it in the oval side where most of the force is going to go up and it's going to start spinning, which will make it hang for longer. So those little details, although we're not explaining, is because the air is going as the ball is spinning, it's going to go like under, create a high pressure, make it go up. We don't go over the stuff. We teach those physical concepts, those physics concepts to the kickers to be much better at doing their job, which is kicking. Also for rugby, hey, if you see this super big guy, much bigger than you, you know that if you hit him lower, the momentum arm is going to make most of their weight work against them and bring them down. So it's all these little details that we don't explain all the physics behind them, but we teach them physics to be better at what they do.
Okay. So you're not necessarily doing equations, but you're still applying those concepts and that knowledge to a specific use case to either allow you to kick better, to tackle better, to protect yourself even. You kind of mentioned earlier, since it is a high impact sport, making sure you're tackling the correct way, preventing injuries, etc. So I love that connection works even if you don't necessarily write out the equations.
Exactly. And this is for the players, right? The players are not writing the equations, but there's a lot of people studying these exact effects. So obviously we can just, from testing ourselves, we can see like what are the best ways to kick a ball. But there's been research done on like, the ball shape, how to kick it, where the air travels and stuff like that. So there's really smart people doing these things and actually sometimes shaping the balls. So for like World Cups and everything, they come up with different balls, slightly different, and they are widely different on how they behave. Although the change is minimal, you can see when you pass it sideways and you make it spin, it floats a bit more, which means the pass will go a longer distance with the same amount of throw. So there's a lot of really smart people that study this, put a lot of thought into it, and make small changes that radically change the game and teach us more about the game.
I love it. Yeah. So again, just understanding these concepts, being able to analyze it, gather data, and then pass that on and teach it can help support a team, can help support an athlete. So the things that you all are doing on your teams can be transferred to a wide variety of industries, from manufacturing to space to now even, as Martina is showing, to sports. Um, I know you played for the U.S. You were on the U.S. under-20 team, I believe, correct? So
Yeah.
you were at a pretty elite level within the sport. Were there any people on staff that you would say have that STEM background? Was there someone that was helping you all with that specifically? I'm sure there was also all kinds of team doctors and other people that are helping overall. But are there any areas that you would say, like, this is probably the person that was applying STEM the most to our team to help us improve?
Yeah, like you said, there were plenty of doctors and trainers that were very, very qualified in the team. So when you think of STEM, you think of science, technology, and math. Like a lot of the people were applying this, like, best recovery ways or best protocols for get us in shape. So when we went there 2 weeks before our game, and in those 2 weeks we were training intensely, almost all day. We were lifting in the mornings, then we go and practice running, then we do another lift session, and that's very taxing on the body. So we got people that did a lot of research on the human body, a lot of research on muscle recovery, muscle endurance, and they will get us through protocols and examine us. So they'll put us in like ice bath, then cryotherapy, then like pressure. They will put like a leggings that inflate to drive the lactic acid out of the leg. Said that. So there was a lot of like real scientists, pretty much like masquerade as like trainers, performing these like things that they had studied before to make us the best athletes that we can be. So we definitely had a lot of stuff with a lot of qualified STEM backgrounds in there.
Love that. Again, helping the athlete perform at the peak takes a lot of science, takes a lot of thought into that recovery to allow them to, be on the field with top performance. Is there, sorry, I just lost
I was
that.
going to say, no, and
Go ahead.
say also, like, we do have a lot of people tracking our performance with data. So something I forgot to mention is they make us wear these little like GPS trackers in our jerseys. These GPS trackers, they're very, very accurate in that they measure our distance. So we will go and practice, and they will like start it, and they can measure exactly how much we ran, the speeds that we ran, our top speed, our average speed, how much we rested, our impact force. So like if we were like one of the players that are bigger and expected to like hit more or more often, harder, they will see that, they will have that data, and if you weren't performing, they will know, and they will try to like bring you up to speed. So if perhaps you were supposed to be the fastest on the team and you're like not so fast, they will pull you to the side and make you do some speed drills. If you were not running as much as everyone else, they'll pull you to the side and make you do some endurance drill. So we will have a lot of data analytics tracked on us, to, again, make us the best athletes, make us perform at the highest level, all with the use of STEM, gathering data and applying it for the best results.
That's really cool. I wouldn't have thought about that in terms of like how much information you can get from a sensor. Our teams, our students, even in first Lego League, when they're 10, 12 years old, they're already using different types of sensors. So maybe some of you out there may find some great ways to incorporate sensors into more aspects of sports. And I was going to ask you on that one, is it a very small sensor? Did it bother you at all? Was it pretty discreet? Like, how advanced was that sensor technology?
It was really discreet, actually. And jerseys come built in, like professional jerseys come built in with a pocket right here, right behind the neck. We also sometimes made us wear like a sports bra. So it's a grab which has like a special pocket, and we use that for training because it was more secure. But for our games, because they will also track us in our games, we'll have it like in a pocket in the jersey, and it was about this big, this thick. So it was very, very small, very discreet, especially when you put it back here, you cannot feel it, you cannot sense it there. So it's pretty impressive how much and how accurately they can track this data. They had like our top speeds to the 0.1, like to a decimal mile per hour. So they knew like exactly like, oh, you ran like, we were doing speed drills this week, and last week you ran, 15 miles per hour. This week you ran 15.5.
Okay.
The drills that we did really improve, or hey, you ran 14. We need to go back and see what you've been doing and fix it.
Wow.
It's very impressive how much data they can track and how accurately they can do so.
Yeah, that's incredible. I think that's something that teams could really relate to and connect with, and skill sets that you all are building right now that could translate to something like this, whether it's in rugby or some other aspect of sensors and collecting data and then making decisions based on that data. Because I think that's another key factor, is having the people that can analyze what's coming in and make good business decisions, or in this case, good sports decisions, to put the best team together, to make sure if someone needs to rest, they rest, or to, like you said, share the appropriate drills.
Absolutely.
Let's touch safety on, or go ahead.
No, I was going to say, yeah, data analytics is a super important field that is growing right now, analyzing the data, and not just from what we think, what we feel, but actually having hard data on what's the best course of action is something very important, something that definitely relates to STEM and everything we do every day as STEM majors.
Perfect. Are there any scenarios like that where, for those who don't know a lot about rugby, are there scenarios like, for example, we had a football player on an earlier episode where he talked about how that data can help them decide, do we go for a field goal or do we go for a pass to try to get the first down? Are there scenarios in the game that then you might take, not necessarily your sensor data, but other types of data and information, and then try to make a decision on how you should approach the next play?
Yes. So I think, rugby is more closely to soccer than football in the sense of like the plays. So rugby doesn't really stop, and you don't communicate with your coaches during the game. But that being said, there is a lot of data and data analytics taken from the game. So we are taught, part of our training is classroom training, and we are taught like, we have done a lot of research in a lot of professional teams, and we know that a good example that they gave us, the faster the ball leaves the ground, the likelier you are to score. So they did like a whole bunch of research on teams. And in rugby, when you are carrying the ball, you get tackle, you go down and you place the ball, and your team picks it up and keeps playing. The ball is live. How fast that transition is between you hitting the floor and your team taking out the ball has been shown to be incredibly important to like a better scoring on the game. So we've seen a shift on rugby of much faster plays because they see how important it is. So in the classroom, they teach us, hey, the techniques that we would tell you, we need to improve it this way, and here is why. If you get it down below 3 seconds, you are 20% more likely to score.
Okay. Wow.
That's just one example. Like, there's a lot of decisions. We have penalties, and the penalties we can decide to basically pick it up and run forward, or we can kick it to the sideline, and then we get like a soccer throw where you throw it back in.
Okay.
And there's, again, research done on depending on where you are on the field, which is the best decision to go forward. So if we are like within their 50-meter line, so like in their side, we should kick to the sideline, because set pieces or like things you do after you throw it from the sideline are much more likely to score, or at least gain yards, than if you do it behind your line. And so there's a risk factor. So you can basically do like a risk reward analysis on each play. And this is all again based on data, because if you kick it from here, 50% of the time you're gonna score, and there's 30% chance you're gonna lose it. This is like a risk we're willing to take in rugby. But if it is 80-20, in like we're probably gonna lose it, then we're not. So it's definitely a lot of data, a lot of STEM used to assess decisions and make better informed decisions when it comes playtime.
This is awesome. I did not think there would be this many examples. This is so cool. It's that deep into
Mm-hmm.
the info from your jersey sensors, the decisions you make on the field, and how you react to that. Training, recovery. There's so many good examples. So everyone keep throwing the hearts. I see lots of hearts coming. I see more people sharing what countries they're coming for. Saludos a todos los que hablan español. Vamos a hacer otro live en algún momento en español.
Exactly.
So all the Spanish speakers will have to come in and do another live in Spanish at some point. But we appreciate you here. I want to go to a question that was put into the chat. And so guys, keep throwing your questions in, because I want to address some of these that you guys are curious about. And it's from me_oro. Says, I was just wondering, how would the sensors help players avoid injuries? And I want to talk about just safety and injuries in general, because it is a sport, from looking from the outside, that it can be very dangerous. There's not a lot of padding or equipment. It really is you and the field and the ball, right? So if you could address that question a little bit, and maybe some other thoughts on just general safety in the sport.
Absolutely. So actually, because of all the data that we've been gathering in this later years, rugby has moved on to implement rules and other regulations to make the sport safer. So there have been things that are called set pieces, scrums. So that's when two teams basically lock shoulders with each other and then push over the ball. Over the years, they have been regulating more and more, because they notice that causes a lot of neck and shoulder injuries because of high impact, initial impact. So we were able to keep that set piece, which is essential for the game, but like alter it slightly so the impact is not as hard and is much safer for the players. And another very interesting piece about data analytics is that this data is not just recorded for rugby, but also for football. And what we have discovered is that football players, and this was research done into, should we use more padding or more protection? And the clearest example is football. Is similar in nature, but they use a lot of protection. So they found that football players, because they have that sense of confidence in their pads, in the helmets, in that protection, that they hit much harder with much more force, sometimes 3 times as much force. And that transfer momentum, especially when you do it, if you think of your shoulder, it is, if you train your shoulder a lot, it can be very hard, very sturdy. But when you put a pad in front of it, it's much harder. So when you hit 3 times harder with a much stronger surface, the injuries are much worse. So what we found is that actually maybe we should not implement more padding, because it will lead to players having that false sense of security and hitting harder, which will injure them further. But yes, all this data has been used very extensively. And if you look at rugby 30 years ago, 40 years ago, and you look at it today, it's a very different sport. And a lot of that is all to make it safer, all to add regulations, add techniques. A lot of tackling regulations have been added, because they found that, for example, when you pick up someone and they drop, that causes a lot of injuries because of the impact with the floor, not so much of the hit. So the hit was fine. We can leave it in. But we should avoid the lifting. So we've been adding regulations and safety changes to improve the sport. And this all have been based on research data gathered from these sensors, and also from obviously post-game analysis on the players and things of the sort.
This is awesome, because it's such a good example of how engineering and science should work. Like, you take data, You take scientific learning and discovery, you take tests or lab things that you've done, and then you find out what's the best way to then implement that into the real world. And so you're taking the data that you're getting from the game and then adjusting the rules, adjusting the gameplay so you can continue to have a exciting but even better and safer product. So this is perfect example for what students might be able to do from their robots and gather information and then try to improve, and what you'll be doing in your future careers wherever you all land in the future. So the person that asked the question says, thank you for that. Funny you mentioned football. I was just thinking about brain damage specifically in that sport. So to all of the students, if you have thoughts on kind of ideas, or you're working on football or sports or these type of high impact fields, this is something that you can, send your ideas over to Martin and I, and we'll see, what we think about those, because that's kind of one of my biggest goals with this series, is that the students will be inspired by something that you shared. They'll go on and go to the drawing board and try to create something and then bring it back to us, and we can share some of that with the world. So all kinds of great stuff coming out of that. And the hearts continue. We've got more people hopping in, some from robotics team from Long Island. We've got the first Lego League team, Strong Brain from Brazil. Again, people from all over the place. So keep throwing your questions in there. And I want to head now towards, is there an area where you feel like we've just been doing this how it's always been done, and maybe there could be some technology that would help or improve the sport, but there hasn't been anything added? And I'll give you an example to get you kind of a thought starter. And Eric Alejandro, the hurdler that we had on the show that you're familiar with, he was talking about the bibs for athletes in track and field. So it's just a piece of paper with pins, right? And that has never evolved and changed, and that's how we identify athletes, right? There's got to be a better way, an easier way, or maybe we don't even need that anymore. But that's kind of how it's always been done. Do you see that there's something like that in rugby, where maybe some technology could change and continue to impact and evolve the sport?
I think there are some areas where there's some improvement to be done. I think one of the big ones is we do have some helmets in rugby, but they're not like football helmets. They are like just of a very soft, squishy fabric. And what most people don't understand is that the reality is they're to protect the ears, really. Because when we do these set pieces called scrums, as I described earlier, as two teams locking against each other, there's people that basically position themselves behind the first three players, so in between their hips, and their like heads get put in between their like hips or like their legs. And what happens, there's a lot of friction between the ears and like the players. So they usually, sometimes they can cause damage, like burns or like inflammation and things like that. Two problems with this are, first of all, a lot of people that are not very familiar with the sport take it as a protection method. So again, because they have a helmet, they feel safer, so they hit harder, which leads to injury. And another one is that they have a lot of padding in the ear that prevents them from listening. And that is a very critical part of rugby, because like I said before, rugby, unlike football, once you get hit and go to the floor, the ball is live. You're still playing. And on the go, every second, people are like talking and communicating, calling the plays, calling our next move. So it's extremely important that you're listening at all times what everybody's saying. So if you miss a call, you might, run to a side you might not supposed to. You might do something that you was out of place and throws off the entire team. And this is commonplace. I wore it for some time, and I just had to get rid of it because I couldn't listen. So another fix was just putting tape around our foreheads and within our ears to keep it like this. So I did say that there has to be a better way to do this protection, where we can make like a ear protection that protects the players, and perhaps an actual helmet of soft material that can protect the players, but they serve their own unique purposes and they have research based on them. It's not just like, oh, we have had this like, squishy helmets for like 40 years and they worked fine. So
Yeah.
I
No,
think that's a big area of rugby that needs some improvement.
good. That's a great example. So teams, if you're listening to that, some type of protection for your ears, but that can still allow you to hear well, but then still provides that layer of protection in those difficult situations. So I think that's a great area for someone to start thinking about. How do we invent something like that? If you do send Martin a pair of your prototype,
I would
I'm
love to
sure
try
he'll
it.
test them out for you. That's great. I'm glad to hear that example, because it's something that we, sometimes again, you take it for granted and it's the way we've always done it, but that's the worst way to prevent innovation, is just to say this is how we've always done it. So
Exactly.
I'd love to see some teams work on that. Right along that kind of line, and maybe it's this, maybe you have some other answers. If our teams were to go out and work on something that you think could really change the game, and you had almost like a magic wand and could say, hey, I want to create this for rugby, or you can use other sports that you've played in, because I know you mentioned you've done a bunch of other sports. What type of innovation would you really like to see in sports for these teams to work on?
I think um, I think there's a lot of areas, and it obviously depends on the sport that you're working on. But I think something that is very imperative to rugby is some sort of like quick injury detection device. So
Okay.
uh, obviously, if you're bleeding, if you're like have a broken arm or something, it's very easy to identify.
Yeah.
But rugby, it has a sometimes so like a culture of like, it's a contact sport. We get hit, so
Mhm.
sometimes it hurts, but we'll keep playing. And I have heard from a lot of other athletes that like, like I hurt my shoulder, I hurt my knee, but like I love it so much. I want to keep playing, and it's not impacting me so much. So in rugby, there's big hits, and in the moment, doctors go run and just examine it. Perhaps if it was a device that could, for example, when they grab your knee, in order to test if the knee it has a broken or like a ligament has been torn or something, they grab the knee and they test it. So like they basically grab it and they pull it in different directions and they assess the resistance. They assess how much the displacement of the knee, of the muscles, of the bones, and then also like the resistance. But it's very
Okay.
much like by experience, like I think this is good resistance.
Yeah.
There was some way to like test, like get a measurement of that resistance of what it should be, or perhaps a device that once you do those actions, it measures what's the resistance. So like not perhaps not something that does the action itself, but can measure the resistance, can measure the displacement, and
Okay.
based on that data, it can say, it might be this, it might be torn. Same thing with shoulders, like if you move it different directions, and it hurts or you're unable and inflammates, it can be detection, like early detection for athletes, not to like, oh, I feel fine, I want to keep playing,
Yeah.
which is something I see a lot in rugby.
Okay. That is
Something,
genius. Go ahead, though. Keep going.
yeah, and I was gonna say it's like something very important because, again, in rugby and I think in football I have seen it a lot. Is it's kind of like a bit of pride, like if I can keep playing, I'm gonna keep playing. But especially when we're talking about professional sports and just amateur sports for health, sports should be at the end of the day fun. Should be a hobby. Should be something
Yeah.
that complements your life, not that detracts, that makes it worse. So if you do have an injury, even if it's small, you shouldn't push it any further. You should recover and get better for next game. So something that can accurately measure that resistance, accurately measure that displacement, can save people from, oh, I have a little, like, it bothers me a little bit, but like I'm going to test it for 2 more weeks. And in those 2 weeks period, like, you further the injury much more. It can be something that changes the game forever. Like early detection injuries, treat them, get them ready for the next game, can save many, many injuries in the future.
That is genius. I know that mindset as a runner. You know, you get that little pain. You're like, oh no, I'm just gonna push through. I'll go 1 more mile and see how it feels, and then that extra mile, it could be the thing that actually makes it that much worse. Versus if you would have just paused in that moment and rested, you'd be fine. So I love the idea. Teams, I guess in general, if we put it in a nutshell, it's different ways to detect whether an injury has occurred or potentially could happen soon. You know, the more information we could have, the better. But I think that could be a game changer in all sports, and even just in the field of medicine in general, because people get injured doing household tasks or things in the backyard. You can make a significant difference on the industry, and it makes me smile and laugh a little bit because I think of like WebMD. So like when you go and you start putting in your symptoms and then you find out, you're like, oh no, I'm gonna die. And it's not necessarily the case because it doesn't have all the right information. And it's trying to make a guess based on some of the things you're talking about. Same with the team doctor that's going to you to check you on the field. They're making their best educated decision in the moment, but there's all kinds of different factors. The adrenaline in the athlete, even when they're getting up after that and they think they're fine, and there's other factors that could be contributing. So if we could find a way to get into our bodies and really get all that information, that would be absolutely incredible.
Yeah, absolutely.
I love that. And so I want to give you a chance now. I know that you're working on a scholarship that is not necessarily specific for STEM students, but I know it'd be great. You'd be excited if it did go towards STEM students. Can you share a little bit about the scholarship initiative you're working on and who might be interested in applying? Because I know our audience has a lot of very talented students that may be interested.
Absolutely. So the scholarship, it is called Querer Poder Scholarship Fund. It's a memorial scholarship for my mother, who recently passed. She was an avid advocate of education, mainly to achieve one's dreams. She always believed that, you know, if people were given that opportunity to chase their dream, to go educate themselves, not only will we all have a better society, a lot of educated people making the world a better place, but if you give someone that is in need, that like needed that opportunity to go to school and make their dreams come true, it is much more likely that they will do the same. So we can create this like giving back system of perpetually helping people that were in our place. Also, another thing that she believed is that if we want leaders of tomorrow to look like us, to be like us, we need to impact people and kids going to school today. So the scholarship, Querer Poder Scholarship Fund, is going to go to high school students going to their first year of university. They are first generation, or the first one in their families to go to university, of low income and underrepresented, which would encompass anything from Hispanics, Latinos, African American, Asian American, LGBTQ, any group that is currently underrepresented, and has gone through sort of like, a hardship. What we really want to emphasize is that we want everybody here is bright. Everybody trying to go to school is an amazing person, but some people, perhaps don't have the best scores or the best grades because they were taking care of their family at the moment, or they had some other hardship. And those people, I feel, in my opinion, and my mother's also, they should also be rewarded. So that's who it's gonna go to. And currently, it's on it's not application basis. So people applying to University of Virginia will be chosen that meets these requirements. But my goal for one day is to grow it to a point where this scholarship is no longer a scholarship, but it's a foundation that helps students with anything from college essay applications to mentoring to college prep classes. And it also gives scholarships to students to go to any school in the country. So currently, like you said, I'm doing a fundraiser for the scholarship. I went to the program Exathlon, to raise money for this cause, and I'm doing a fundraiser to get the rest of the money. So if you guys want to learn more about the scholarship Querer Poder Fund, you can head to quererespoderfund.com, where you can learn about the scholarship, who's going to go to, and most importantly, learn about my mother, the one that made all of this possible. And if you want, you can donate to this cause to help students of all paths of life go make their dreams come true. So
I love it. I love what you're up to. I love the mission behind it, the passion that comes from your mother's story and what you've been able to accomplish since then. So any students that are interested in the University of Virginia, definitely take a look at that. But then also understand that for students, you have access to over 90, I think it's $90 million worth of scholarships. So make sure that you're applying, make sure that you're at least going over to the scholarship page on firstinspires.org and understanding what's available. Also take a look at Martin's scholarship, share and spread the news. There's definitely tons of money for students in STEM, especially if you come from an underrepresented background or you're just really passionate about a particular area. There's a scholarship for people with purple hair that want to go to space, and there's all kinds of scholarships out there. So no matter where you come from, what country you live in, what school you want to go to, make sure that you're checking out all of the scholarships that are available out there, especially those that are provided specifically for first students, because that narrows down the pool, right? You're only competing against other first students for those dollars, and make sure that you're able to take advantage of that. I know both Martin and I were benefited significantly from scholarship donations. It makes a big difference, and then also once you're done, if you can give back in any way, like Martinez, that's an absolutely wonderful thing. So thank you for what you're doing there. And I want to ask you just one last question to close it out, and that's around the idea of perseverance. And so partially because of just the pandemic and everything we've been living in and the challenges that people are facing, in addition to all of the challenges we already had, and the challenge of wanting to be an engineer or STEM major in the future, which is already challenging enough itself. What are some of your thoughts and tips around perseverance? You and I had a very similar experience on Hexathlon where we were challenged. The percentages weren't always the greatest, but we kept fighting and we kept fighting until the last minute. So what are some of those things that you learned, or whether that's from Hexathlon or from other aspects of your life, that have helped you keep moving forward when things were challenging? What can you share with our students that may be going through those struggles right now?
Absolutely. And I think this is a perfect way to plug back in my scholarship, because querer es poder, that's what it's all about. It basically roughly translates, if there's a will, there's a way. And I feel like perseverance is extremely important in every path of life, but especially in STEM, or anything you propose your life to, because we don't have to be the most talented. We don't have to be the best at math or physics or really anything. It's all about, like, if this is something you're passionate about, you can find a way to make it a reality. As in my example, in university, I was actually really bad at math. So I went to office hours nearly every day. And that didn't make me a worse student. Actually, I improved. I came from being one of, like below average, to being on the top of the class, simply because of that perseverance, simply because of, sometimes you might have to do a little extra work. Sometimes you might have to, put in that extra effort. So if you want to go to school, I'm sure it happened to you. We didn't have much money, so we had to look a ton around for scholarship, apply for scholarships. But perseverance, finding a way, really wishing, having that wish inside of you, that passion, that drive, is gonna make you find some sort around that obstacle. There's never an obstacle too high. There's never an impossible task. As an engineers, we know that every huge problem can be broken down into very small problems that we can tackle one step at a time. That's my best advice. Never be scared of the size of a problem. Never be scared of the magnitude of the challenge. Breathe, break it down into small problems, and figure out a way to defeat every problem one step at a time. without perseverance, neither of us will be here. And I'm assure you that most of engineers and athletes can tell you the same. So always keep fighting, and always remember, querer es poder. If there's a will, there's a way.
I love it. And I'm gonna pin so I'm gonna pin the comment here with the website. But I think that's perfect in the sense that there's more than one path also, because just because it didn't go the same way as someone else did, or someone else seems that they're doing better off, it doesn't mean that's the only path towards the goal that you want to accomplish. So keep that ese querer, that like will to keep fighting is more important than any accomplishment along that road, because that's your fuel, right? That's going to get you there in the long run.
And I think it's very important that like there's not a straight path. There's not like, in order to be the best aerospace engineer, I need to do this internship and this and that. There's like, I think most engineers can say like our path looks all over the place until we really found our niche, until we really found what motivates us. And throughout the whole time, it's our passion that drove us forward. Is that like, that idea, that dream of finally making it there, is what kept driving us, and what I really encourage you all to have, to keep that drive alive, to keep pushing forward, until you see it through.
That's wonderful. Actually, I'm gonna have one last thing, because I know we often have mentors and sponsors on the call. You're actually open for work right now, right?
Yes.
So if there's any aerospace engineering leaders on listening in, definitely take a look at Martina on LinkedIn. Am I correct though? You are looking for work right now?
Yes, I am currently looking for work in the aerospace industry, focused with spacecraft systems engineering or design engineering. So that's the goal. Actively looking for. And on the same route, I'm also definitely open to mentoring or reaching out. If anybody has any questions, needs any help, I love to mentor. I love to help. So please feel free to reach out, send me a message. If I don't see it right away, send me another one. Don't be scared to reach out. I would definitely love to help you if you have questions with your projects, schools, engineering, anything it might be. I love to help. So.
That's perfect. That's such in the spirit of FIRST. And also, FIRST has a lot of supporters in the aerospace industry, so I'm sure we'll get this in front of someone who will be inspired by what you shared. Your heart, your servant leadership mentality, which I love, and I'm happy you're able to share with our community today. And then, teams, if you have an idea that you want to share with Martin around any of the STEM that he talked about today, or if you have a question that you kind of didn't get the full answer to today around the project that you're working on this season around sports, definitely send him a message so you can continue to explore that. And then definitely, if you come up with some type of prototype or a concept, please share it with us so that we can then continue to spread that. Whether it was Martin or any of our previous guests, we definitely want to highlight any teams that took something from this call and then started working on it. And then any mentorship support, feel free to reach out as well. So thank you, Martin. This was an absolute pleasure. I never would have thought we'd have this much awesome STEM to talk about in rugby, but it's just so cool. And I'm excited to now that I know some of these things, kind of try to point it out next time I watch. We've got students from all over the world, definitely some very popular countries where rugby is very popular on the call today. So thank you for your time. Thank you for your expertise. And I can't wait to go to a first event with you once things get back to in person. We're definitely going to go to one, and I'll hit you up for that.
Absolutely. Again, thank you so much for having me. Like I said, it's a great time to talk about STEM, great time to share. Always, it's a pleasure to help and be part of the process. So please, always here for the next one.
Excellent. Thank you. Have a good night, everyone.
Take care.